All right, so if we treat this top as one single fraction and we combine it into, or one single expression, combine it into a single fraction, we need to identify our LCD. We need a factor of x minus 1, a factor of x plus 1. So we can take our numerators, the original numerator of the first fraction, multiply that by any LCD factor missing from its denominator. It's missing the x plus 1. And then we'll subtract the next fraction's numerator times any missing LCD factor from its denominator, the x minus 1. And so if we distribute, what we have here is a x squared plus x minus x squared plus x. Again, the x squareds will cancel, leaving a 2x in the numerator, the x minus 1, x plus 1 in the denominator. Okay, and then we can do the same thing with fractions in the denominator. Combine them. The LCD is once again x minus 1 and x plus 1. The missing LCD factor from the first fraction's numerator, or from the first fraction's denominator, is still x plus 1, plus the next fraction's numerator x times the missing LCD factor from its denominator, again still x minus 1. And if we simplify, we get an x squared plus x plus an x squared minus x. So here the x's cancel, leaving 2x squared all over x minus 1 and x plus 1. And so now if we take this fraction and convert it into a multiplication problem, so that we would be dealing with 2x over x minus 1 times x plus 1. And instead of dividing by it, we'll multiply by the reciprocal. The 2x squared gets moved to the denominator. X minus 1 and x plus 1 move up to the numerator. And if we cancel our common factors, x minus 1, x plus 1, the 2's cancel. This x cancels with this x, leaving an answer 1 over x. Now what values do we have to restrict from this? We canceled out a factor of x minus 1 and x plus 1, so x cannot equal plus or minus 1. Okay, so that would be your simplified form with the correct restrictions. Now, again, this is one of those problems that's conducive to the second method because there's only two distinct factors for the LCD. So if you thought of this whole thing as one fraction and you want to get rid of the denominator for each individual part, you can multiply by the LCD of everything involved in this whole problem. So that would involve taking the LCD x minus 1, x plus 1. Here it's not unique, we already have it. Not unique, we already have it. So here is your LCD for every term in the entire fraction. So we'll just write that over itself to give you a value of 1. And when you distribute through, you wind up with x times the x minus 1's cancel, so you get x plus 1, minus x times here when you distribute through the x plus 1's cancel. And then in the denominator we do the same thing. Again, you're treating the numerator and denominator separately. So we get x times the x minus 1's cancel, leaving an x plus 1, plus again x. Here the x plus 1's cancel. And so here's your single fraction. When you distribute through, again, just like we did up here, we'll wind up with a 2x. When we distribute through, just like we did down in this area, we'll wind up with 2x squared. Canceling leaves you with the same answer here. Remember, if you do use this second method, again, you can see it's less writing. I solved everything that I solved up here. I solved in just this small portion. So it might save you some time in writing. The one thing you have to do, though, is go back and check all the domain restrictions in the original problem in order to find it, because you aren't going to see those factors canceled out in the denominator.